Happy Tuesday. I'm going to look at different types of coordinate systems. Again, natural extension of Calc 2. One of the last things you should have studied in Calc 2 was polar coordinates. It's just an alternative coordinate system in 2 dimensions, right? Polar coordinates consists of 2 perpendicular axes, the r-axis and the theta axis, right? R measures distance from the origin to the point. Theta measures the angle that the line segment OP makes with respect to the positive x-axis. Two additional coordinate systems in 3 dimensions: cylindrical and spherical. What cylindrical does is it has 3 axes: r, theta, and z. R and theta are the same as polar. Z just represents height. So it's height that the point P is off of the XY plane. And of course, it's assigned height. So if it's above, it's positive. It's below, it's negative. Then you have spherical. 3 axes in spherical: rho, theta, and phi. Rho is the distance from the point to the origin. Theta is the angle that OP prime makes with respect to the positive x-axis. P prime is the projection of the point onto the XY plane. So theta is basically the same as it is in cylindrical. And then phi is the angle that OP makes with respect to the z-axis, the positive z-axis. That is known as the angle of declination. Should already have that. So I'm going to be given a bunch of points, and we're going to be asked to convert from one coordinate system to another. 3 pi over 3 negative 4. That is cylindrical, and we want it in rectangular. There are 6 relations for cylindrical and rectangular. 3 if we're going from cylindrical to rectangular. 3 if we're going from rectangular to cylindrical. What's one of the 3 to go cylindrical to rectangular? It's another one.
Y equals r sine of theta.
Which one of the 3 to go rectangular to cylindrical?
theta equals arctan y over x.
Okay, be careful because that is not the relation. Relation's tangent of theta is equal to y over x. And you can't just take the inverse tangent of both sides for the reason that we explained on the first problem set. Right, inverse tangent only gives you quadrant 4 and quadrant 1, but you could also be in 2 and 3. What's another one? Right, that is technically the relation. In this case, we would be safe, just take the positive root of both sides, right? R measures a distance, so it's never negative. And what's the third? Z is just equal to Z. Ordered triple in rectangle is always X, Y, Z. Ordered triple in cylindrical is always R, theta, Z. X equals R times cosine of theta. What's cosine of pi over 3? Here. It's a half. Y, R, sine theta. And sine of pi over 3. And finally, the toughest one. Z is equal to Z. Point in rectangular is 3/2, 3 root 3 over 2, -4. So from rectangular to cylindrical. R squared. X squared plus Y squared. So that's equal to 8. It means r is 2 root 2. Tangent theta is equal to y over x. Now you have to ask yourself, looking just on the xy plane, what quadrant is theta going to be located in? Second quadrant. Does inverse tangent give us a quadrant 2 angle? So you can't just take the inverse tangent. If you take the inverse tangent, what quadrant are we going to wind up in? How are we going to get to the second quadrant? Flesh. Call that theta prime. That's what it's going to give us. You just add pi, right? Because the angle we want is that one.
Is it that one?
Well, remember, -1 itself is what tangent theta equals. Right, so this is the angle that we're going to get. So you have to think of the unit circle. Right, so if you draw a unit circle, terrible looking unit circle, but whatever. That's the point that tangent theta would refer to. Right, so x is -2, y is 2, so that point would have been -2, 2. Right? Hold on, wait a minute. Yeah, right. -2, 2 is actually over here, right? This would have been 2, -2, which is what the inverse tangent gives us. What is the inverse tangent of -1? Radians only. Oops, I did a 3. So our theta is 3 pi over 4. And z is just equal to z. That would be our point in cylindrical. The convention for theta is to be an angle between 0 and 2 pi. But that's not a hard set rule. We could have also done, what, 11 pi over 4? Or you could subtract 2 pi instead, which would have been, what, negative 5 pi over 4, right? So any angle 3 pi over 4 plus or minus 2 pi would work. But the convention, again, is 0 to 2 pi. So that's what I'm going to stick with until we get to multiple integration. Then I'll consider negative angles. Spherical is rectangular and vice versa. As with cylindrical and rectangular, there's a total of 6 relations. 3 to go rectangular to spherical, 3 to go spherical to rectangular. What's 1 to go from spherical to rectangular?
That row is this from the x-axis.
From the origin to the point.
X squared plus y squared, u squared.
True, that's not a relation from spherical to rectangular, though. That'd be 1 from rectangular to spherical. X is rho cosine theta sine phi. Y is rho sine theta sine phi. Z is rho cosine phi.
Fancy P.
It's the Greek letter rho. Yeah, it's kind of like a curly P sort of thing. Don't ever go away. Yep. That's rho. Lowercase rho. Rho squared is x squared plus y squared plus z squared. Again, by convention, we always take rho to be positive because it's measuring a distance. So you could just take the square root and say rho is positive square root of x squared plus y squared plus z squared. Now, theta is the same theta as from cylindrical coordinates. Which means that relation is going to be the same. Now for phi. This is the relation for phi. Cosine of phi is z over the square root of x squared plus y squared plus z squared. But that square root is rho. So you'll typically see me write cosine of phi is z over rho. Just because I'm lazy and don't want to write out square root of x squared plus y squared plus z squared all the time. What is the range for the inverse cosine? I can see these are going to be my best friend for the next couple of days. Uh-oh, we don't remember a pre-calculus. Range for inverse cosine. 0 to pi inclusive. Would we be able to just take the inverse cosine on both sides? Bless you. So if z is negative, what would the inverse cosine give you? An angle between what values? So think of it just now in terms of quadrants. Inverse cosine will give you quadrant 1 and quadrant 2. So if z is negative, inverse cosine would give you an angle in what quadrant? In other words, what quadrants are cosine negative in? Two and three. Remember, cosine represents the x. So if z was negative, the inverse cosine would give you a quadrant 2 angle, which is pi over 2 to pi. That's fine. In this case, you can. Phi is an angle between 0 and pi only. And it's measuring angle of declination. Does not matter what side of the z-axis the line segment is. Right, so you don't have to worry about angles between pi and 2 pi. We just ignore everything else and say, look, here's our z-axis, right? And say that's the origin. Let's actually draw up the scale. Those are the same angle. And it's measuring the same declination from the z-axis, just on opposite sides. So phi is always between 0 and pi. So in this case, you can always just take the inverse cosine safely. Right? If z is negative, it lies below the xy plane, right? Well, on the xy plane, that angle of declination is pi over 2, isn't it? It's a 90-degree decline. So if it's below, obviously you're going to have an angle larger than pi over 2. Which is nice, which means the only thinking we have to do is with the inverse tangent. We're going spherical to rectangular. X. Rho. Cosine theta. Sine of phi. Right. Again, order triple for spherical is always going to be in the order rho, theta, phi. What is cosine of pi over 4? What is sine of pi over 6? Simplify that, you get 2 root 2. Rho. Sine of theta. Sine of phi. What is sine of pi over 4? Of course, we know sine of pi over 6, so y is also 2 root 2. Z is rho. Cosine of phi. What is cosine of pi over 6? Makes the z coordinate 4 root 3. The point in rectangular coordinates would be 2 root 2, 2 root 2, 4 root 3. Rectangular to spherical. Rho squared. X squared plus y squared plus z squared. Twelve plus 36 is 48. 48 and 16. 64. Makes rho squared 64. Which makes rho 8. Tangent theta. Y over x. That's going to be 3 over root 3. Again, now just looking at the XY plane, what quadrant is the projection of our point located in? First quadrant. So can we just take the inverse tangent? We can.
X and Y,
Yep.
not free.
Correct. Right, because 3/√3 being positive gives you two possible quadrants, right? 1 or 3. Right, you have to actually look at the signs of X and Y to determine. What is the inverse tangent of 3/√3? Pi/6? Pi/3. The easiest way to do this is to realize that 3/√3 is just the same as √3, which is √3/2 over a half, which would be sine of pi/3 over cosine of pi/3. So the inverse tangent is pi/3. Finally, cosine of phi is z over rho. What is the inverse cosine of -1/2? Our point in spherical coordinates is 8 pi/3, 2 pi/3. Huh?
The denominator.
Square root of x squared plus y squared plus z squared, which is rho. Yeah. Bless you. Well, that's all well and good. Except, more often than not, we are not interested in converting a single point. We're interested in converting a set of points. Right? Remember, when you look at a function or a relation, That is defining a set of points, right? The equation x squared plus y squared equals 1 is the unit circle. It defines a set of points x, y that satisfy x squared plus y squared equals 1. Specifically, every single point on the unit circle. Now just convert that to cylindrical and spherical, and you have the same idea. Going to convert x squared minus y squared equals 25. First, we're going to convert two cylindrical coordinates. Right, so we're converting the set of rectangular points to a set of cylindrical points, and this is extremely important when we move on to multiple integration. Being able to do this quickly is very important. But we have 6 relations, right, dealing with rectangular and cylindrical. We know that x is our cosine of theta. We know that y is our sine of theta. R squared cosine squared minus R squared sine squared is equal to 25. Right, factor out R squared. We have cosine squared minus sine squared left. So R squared times cosine squared minus sine squared is equal to 25. Notice that this gives us an implied domain. We can't have cosine squared minus sine squared being 0. Otherwise, we'd have 0 equals 25, which is nonsense. So we've eliminated what odd multiples of pi over 4. This can still be simplified. It's R squared cosine of 2 theta. Plus is equal to 25. This would be fine. You can leave it like that. Okay, that was odd.
Cosine 2 theta.
Yeah. If you're doing problems like this from the textbook, it might try to write it in the form R equals a function of theta and z. Right, so it may write this instead. Right, but of course, R is always positive. So it might try to do that. They're both fine. X squared plus y squared minus z squared equal to 1. We want to write this in spherical. Right, well, X is rho cosine theta sine phi. Y is rho sine theta sine phi. D is rho cosine of phi. If we just look at the first two terms, there is a rho squared sine squared phi common, factor it out. Notice what you're left with, the cosine squared plus sine squared, which is 1. This simplifies then to rho squared sine squared of phi minus rho squared cosine squared of phi. By the way, that is an identity that you may want to keep handy in spherical coordinates. X squared plus y squared is rho squared sine squared phi. That, of course, means r squared is rho squared sine squared phi. Or r is rho sine phi. Can factor out a rho squared? Rho squared is sine squared phi minus cosine squared phi. Or rho squared times sine squared phi minus cosine squared phi equals 1. That can be simplified. To negative rho squared cosine 2 phi. So rho squared cosine 2 phi is equal to -1. Again, the book tends to write it in the form rho equals a function of theta and phi. So you might see that written as rho squared is equal to negative secant of 2 phi. Right? Or rho is the square root of negative secant 2 phi.
Sure about the identity, right? What's the identity again? X squared plus y squared equals. Sine squared.
Phi. Yep. Right. We actually just derived that within this problem, didn't we? Which is why I say you may want to just take note of that. Now that's only for spherical. Hmm. A way to simplify this, I do not think there is. Aside from factoring out a rho, oops. I mean, you can use product to sum identities on cosine theta sine phi and sine theta sine phi. I don't know if that's going to simplify anything. I just make it look more hideous than it already is, so. Say just stop there. This should actually be number 7. Because I don't know how to count. R equal to 2 sine theta. Want this in rectangular. Right, well, we know that R is the square root of x squared plus y squared, right? How are we going to write sine of theta?
It'd be like y over square root of x squared plus y squared.
Are you asking me if that's what it is, or are you telling me that's what it is?
I think that's what it is.
You think, shouldn't think.
Well, I've never.
Confident.
It is.
You know that's what it is.
Of course, it's what it is.
Yeah. Isn't sine of theta y over r in trigonometry? The y coordinate over the distance between the origin and the point? Which is just y over square root of x squared plus y squared. Means that x squared plus y squared is equal to 2y. Okay, just multiply both sides by root x squared plus y squared. Okay, move 2y to the other side. And then complete the square. So we have a circle centered at 0, 1 of radius 1. Technically, it's a cylinder. Remember, if you just look at the xy plane, right? So it's the circle centered at 0, 1 of radius 1, located right on the xy plane. Has no height. And this one. This one's fun. Might leave this one for Thursday. Any questions?
There should be a.